Chapter 26 review. Number 1, true or false? The p-value of a test equals its observed significance level. Oh man, that's a hard one. So, yeah, I think it's true. We're testing it against a 5% significance level, right? So the p-value is going to tell us whether we're higher than 5% or lower than 5%. So I would say true. The alternative hypothesis is another way of explaining the results. It says the difference is due to chance. The alternative says the difference is not due to chance. So that would be false. I don't know why they don't have answers for these, because I get them wrong. All right. With a perfectly balanced roulette wheel, in the long run, red numbers should turn up 18 times in 38. To test its wheel, one casino records the results of 3,800 plays, finding 1,890 red numbers. Is that too many reds or chance variation? I need to set up a box. What's in the box? It's not 1, 1, and 1, 0. We could say 18 ones and 20 zeros, but we would rather do percentage. So 18 over 38, it's going to be 0.474. So 0.4741s, and then that would be 0.526 zeros. That right there should tell you never to play roulette. Why? You're in the long run you're going to lose because you're less than 50%. And the payout is 1-to-1. So it's a bad idea. Okay. So my null is going to be 47.4%. So null equals 47.4. Now, how do I know if the next one is greater or less? I need to look at my sample. So the sample said, what was it? 1890 divided by 3,800. And I get 0.497. So 0.497 is to the right, so my alternate is greater than 47.4. Do I do a z-test or a t-test? Z. I have a lot of samples. Okay, so I take my SD, which is the square root of 18/38 times 20/38. So square root 18 divided by 38 times 20 divided by 38. That gives me an SD of 0.499. Then I turn that into an SEP. We could have done SEN, but it's easier to do percentage. So we'll divide that by the square root of 3,800, right? And I get 0.08. 0.08099. That is my SEP. Now what do I do? Z-score. So 49.7 minus 47.4, and then I divide that by my SEP, which is right here. Oh, I did it again. Now I need to divide it by 100. 8 or 0.8. You should have done 0.8. SEP is 0.8099. So my SEP was 0.008099, right? So move that twice and I get 0.8099. So mine has 2. So really, you got 1? 30 the square root of 3800? Oh, yeah. Yeah. Okay. So I get a z-score of 2.8. So when I shade norm, I'm going to go from 2.8 to 5. And it gives me an area of 0.25%, which is less than 1%. So this is highly significant, and we reject the null, and we say the roulette wheel is biased. Oh, I guess I could have read the problem, huh? Formulate the null, and the null says that the percentage of reds in the box is... No, it should be 47.4%. Is equal to 47.4%. And the next one is greater than. Okay, were there too many reds? Yes, but does that mean you want to play this game? No. Why? Even with a broken wheel, the casino still appears to have an advantage. Okay? Which means betting on black is a really bad idea. Right? Okay. And every roulette wheel is going to be biased. It is impossible to build a perfectly balanced wheel. But whatever. You know, there will always be, the reason that this works is there will always be some number that is lower than all of the other numbers, like the 7. We did it. Yeah, we finished it. Okay. 3. One kind of plant has only blue flowers and white flowers. According to a genetic model, the offspring of a certain cross have a 75% chance of blue and a 25% chance of white. For you biologists in here, that means that white is recessive. You went the wrong way, Darian. Recessive. Blue would be dominant. It was. At least you were using the right vocabulary. All right, 200 seeds of such a cross are raised and 142 turn out to be blue. Are the data consistent with the model? So our box, we expect 0.251s. Or wait a minute. It's doing blue, right? So we don't want 0.251s. We want 0.751s and 0.250s. So my null is going to be equal to 75%. And then I take 142 and I divide it by 200. And my alternative is going to be less than 71%. You're right, 75. So 75 goes in the middle, 71 goes on the left. I need an SD, the square root of 3/4 times 1/4. Okay, I'll do it. I don't know. Okay. Do I need an SD plus? I have over 100 draws. That's plenty to make a normal curve. 0.433. So SD is 0.433. I'm going to divide that by the square root of 200 to get my, oops, that won't work. So this divided by, maybe, the square root of 200. And I get an SEP of 3.06%. I need a z-score. My distance is -4 divided by 3.06. So -4 divided by 3.06. And I get -1.3. I know the answer right now. What is it? Except the null. Because it's less than 1.64, which means the area is bigger than 5%. But because all of our tests rely on a p-value, we need to calculate the p-value. So we will shade norm from -5 to -1.0. Oh, what is 1.3, right? And I get a broken computer screen. Here it comes. 9.6%. That's over 5%. So we accept the null and we say it worked. It we we got what we expected, right? So the sample fits the model. Okay? And you know what? Gregor Mendel did not have z-tests when he was doing it. Yeah, and actually if you look at Gregor Mendel's study, he really did a terrible job. Um, his his assumptions were incorrect. He fudged some of the data and changed the world. But he his results, his statements were correct, but his statistics were terrible. Even though he kept really detailed records, um, his sampling method was suspect, and sometimes he didn't get what he wanted, so he threw it out. And anyway, it's pretty interesting when you look at what he actually did. But the science holds up, which was interesting. But he didn't like it when his numbers didn't look like they were supposed to, which we would expect to happen, right? But he didn't have any way of standardizing and explaining chance error, any of that stuff. Okay, what's the next one we need to do? 5. A newspaper article says that on average, college freshmen spend 7.5 hours a week going to parties. One administrator does not believe that these figures apply at her college. 300 students of 3,000 students. She takes a simple random sample of 100 freshmen and interviews them. On average, they report 6.6 hours going to parties. Oh, great. An extra, what is that, 55 minutes away from parties? And an SD of 9. Is the difference between 6.6 and 7.5 real? So 7.5, 6.6. My null is equal to 7.5, and my alternative is less than 7.5. I can't create an SD because it's not a 0, 1 box, so I have to use the SD of the sample, which was 9. SD equals 9. Do I need an SD plus? 100? No. If it was down to 50 or 40 or 30, yeah, but 100 you don't need it. So I'm going to find the SE average, divide the 9 by the square root of 100, which is going to be 0.9. 9 divided by 10. Okay. Then I find my z-score, and what do you notice? I'm not even going to calculate it. It's going to be 1 SE. Well, if we are -1 SE and we shade norm, it's going to be So what is between -1 and 1? 68. So how much is in each tail? Half of 32. So 16. So we already know that my p-value is 16%, which means, sorry, lady, accept the null. And we tell the lady, guess what? Your kids party just like everybody else. All right. 6. In 1969, Dr. Spock came to trial before Judge Forge in Boston's federal courthouse. The charge was conspiracy to violate the Military Service Act. Of all defendants, Dr. Spock, who had given wise and welcome advice on child rearing to millions of mothers, would have liked women on his jury. The jury was drawn from a veneer or panel of 350 persons selected by the clerk. This veneer included only 102 women, although a majority of the eligible jurors in the district were female. At the next stage in selecting the jury to hear the case, Judge Ford chose 100 potential jurors out of 350 persons. His choices included 9 women. A. 350 people are chosen at random from a large population which is over 50% female. How likely is it that the sample includes 102 women or fewer? What do you think? Well, let's set it up. So we would expect, it says over 50, but let's just test 50. And then 100, or 9 out of 100 is 0.9, or sorry, 9%. Do we even need to bother? Because the SD is going to be 0.5. Going to divide that 0.5 by square root of 100. So how likely is it? Extremely unlikely. 100 people are chosen at random without replacement from a group consisting of 102 women and 248 men. How likely is it that that sample includes 9 women or fewer? So, well, let's set that up. So so the first one, the chance of getting 9% is 0. And you guys could work the numbers, but that one was so far off it was obvious. In this case, my population has 102 out of 350. So my population is 29.14% female. What's the chance that we end up with 9% female? Well, it would be the square root of 0.3 times 0.7 times the square root of 9/8. Or wait, no, we're doing 100, right? So we don't need to inflate. Divide that by 10. The square root of 0.3 times 0.7 divided by 10 is 4.5%. Now I need a z-score. My z-score is going to be 20 divided by 4.5, which is a z-score of negative 4.4. What do we say? Reject the null. So not only was the original sample wrong, but the sample of the sample was also way off. So what do you conclude? The clerk hates women. Okay. And then you have to do number 8. That's the last one. But there won't be a video for it.